Okay, so today we're speaking about database performance. So when dealing with big data, it's important to optimize your code to increase performance, especially with database operations such as inserting, searching, and updating rows. So you have to be very careful when your project scales up. You have to maintain it, and you have to keep your code and database optimized because we need to reduce any extra overhead. So in scope of this, I've done some research and experiments, and we can compare the results using different approaches for working with database. So the first approach was using PHP, Laravel, and Elocant ORM. And so this is the benchmark inserting data. So we are testing how long the insert operation takes, how much time it takes, and using different number of customers, using different number of data about any users, and something that contains like first name, last name, email, and so on. So we used a library called Faker to fake data, to create some fake patients, fake customers, fake users, and to calculate the time it takes to be inserted into the database. So this code, as you can see, we use here DB table insert statement, and we insert the whole array at once. The array can contain as many rows as required, but when we try to insert it, it inserts it in bulk. And we will later see that this approach is pretty efficient. It works pretty fast. The next one, there's another approach. We can try to insert using models, which is an abstraction on this. Well, it's like a higher level abstraction. And if we try to do this in a for loop, and we try to insert these customers one by one, we will later see that it takes longer time. Also, we can try updating using Elocant. So there is just a statement DB table and update. And of course, we need to specify which users to update. Otherwise, all of them will be updated. So we update, in this case, all users because we want to test the time it takes to update all users, like 1,000 or more. So there is another version. We can try to do insert on duplicate key update. So in this case, it actually lays on MySQL's shoulders to perform the check whether something exists, whether the row already exists in database, and we will also try to calculate. So MySQL will ignore rows if they already exist. And inserting using Python, well, there was an attempt to try using SQL Alchemy library. And the results, so we will run it later, but for now we can see that 1,000 customers as an array using DB table insert, it took less than 1 second. So inserting 1,000 customers as models using model create, I mean one by one in a for loop, it took the whole 8 seconds. So updating customers, of course, it's less than 1 second. Insert on duplicate key update is also less than 1 second. And update or create is also a long operations. And if we write model, update, or create, it took a little longer, probably based on the architecture of the library of the Elocant, the way it works. So it took 13 seconds. Reading is very fast in any case, so it took just less than 1 second. And Python, using SQL Alchemy, it also took less than 1 second, although a little bit longer than PHP. And also there was an experiment using 10,000 rows. And of course, the results are longer. And as we can see that inserting customers as an array using insert function, it took 2.5 seconds. And then we have 10,000 customers using model create one by one. It took a really long time. It took 92 seconds. And updating took 0.6 seconds. Insert and duplicate 0.37. And update or create took like really a lot. It took 159 seconds. Then there was reading time less than 1 second, and Python insert 1000 in bulk. It took 3.2 seconds. Although there is an option in Scalability, if I remember correctly, to bulk update. The documentation says it works pretty fast if you use that option. So these were the results. We can also test them out. So as you can see right now, the database table is empty. Then we have console command, and we will try to run them again. It's 1000. So all this data is being generated on the fly using the faker library. So it's only pure fake data. And as you can see, that update or create takes some time. It's very easy for beginners. It's very easy to understand. Of course, when you have really a lot of data, it needs some more extra optimization. And let's see what happens in our database. So you can see we have 3,000 customers because we ran that command multiple times. I mean, using different approaches. So everything is here. And if we try to run it again, well, we can compare the results. Well, usually we can see the trend that the first approach is usually less than 1 second for 1000 rows. The second approach is usually longer, like 8.4, 8.5 seconds in average. And updating is also less than 1 second. Insert and duplicate update is also less than 1 second. So the results are pretty much the same in here and in here. So now we have to wait for the update or create method to finish. And it took, 25 seconds. Yeah, it's impressive. Well, but still, if you use an ORM, it is great for beginners. It is easy to understand. It is easy to know the basics, how it works, without digging deep into the MySQL special features and so on. But if you have a pretty big project, you need extra optimization, then of course you need to use some extra steps to achieve that optimization. There has to be another slide, but okay. Yeah. So these are basic results. And of course, I could try and take like 100,000 records. I even thought about taking 1 million records, but the time would be really, really, really long, and the script would die with the timeout error. So as you can see, if you have like really, really lots of data, more than 10,000 rows, it's probably better to divide them in chunks, to use some queues, to use some external libraries to organize queues or framework, and so parse this data in chunks, in pieces, in portions. So if you use more than 10,000 rows per time, of course, it may cause a timeout error. So you have to be like careful with that, and you have to make sure, like, do some tests. Okay, so timeout appears only after like 15,000 rows. So then put a limit like 15,000 or 12,000 rows or 10,000 rows, just to be sure. And so trying these different approaches, you can see that it's possible to optimize the code. So you can say that it's because of the programming language, because it's slow. No, it's not slow. It's just the way you work with it. So if you find another approach, you try to optimize, you dig into some documentation, how it works under the hood, and you can still achieve great results, great performance. So yeah, everything is possible. And also, it's good to use DB transactions. If you use transactions and something goes wrong, it will roll back to the big state it was at the beginning, and now no data will be lost. So by the contrary, if you don't use transactions and something goes wrong during the long database operation, you can lose your old data, and it can be a problem. So using transaction just ensures that you're safe to do some dangerous operations with long data where something can go wrong. So thank you for attention. And I'm ready to hear if you have any questions.